Astronomers have uncovered an event that's defying expectations right now. Right this instant, a group of 7 comets is hurtling toward the Sun, set to reach their nearest points just days apart in October 2025. No such clustering has ever shown up in recorded history. Yet what really amps up the unease about this find is the fact that 3 Atlas, an intruder from a completely different star system, is swinging by at its closest during this precise time frame. The chances of that lining up are vanishingly tiny, unless some force is pulling the strings on these arrivals. Could this be more than a random pass-through, perhaps the start of a darker cosmic event? In this episode, we'll probe all angles and ponder influences that stretch past what science currently grasps. Stick around to the finish to uncover exactly how 3 Atlas might be impacting our solar system. Part 1. A heavens packed with intruders. In any ordinary year, you'd spot 1 or perhaps 2 standout comets that catch attention. Plenty of years go by with nothing flashier than faint blurs visible only through scopes, thrilling just the hardcore enthusiasts. But 2025 feels like the cosmos is staging a grand spectacle for us. Allow me to spotlight the lineup of players that's got experts double-checking their math. Pan-STARRS, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and Neat. These 7 separate comets, loaded with frozen debris and stones from the solar system's fringes, are all converging within a span of months, as if it's an unplanned gathering from the stars. Picture it like this. What if 7 pals from distant states all turned up on your doorstep the same weekend, each swearing they didn't know about the others? It could happen. Totally plausible. Just a fluke? You think so? Odd enough to raise eyebrows about secret plans? Without a doubt. This bunching produces what's known among astronomers as a swarm effect, several comets jamming into a tight viewing period. Viewed from our planet, it seems nearly deliberate, almost as if an unseen shepherd guided them our way. Before we plunge into the heart of this starry enigma, let's lay down a few basics. Perihelion marks a comet's tightest orbit around the Sun, when the Sun's heat vaporizes far-off icy bodies into dazzling streams of vapor and particles. Closest approach describes how close these bodies get to Earth, deciding if you'll need binos, a scope, or plain eyesight to catch sight of them. Magnitude gauges how bright they appear. The smaller the figure, the more radiant the sight. A rating of 6 is tough to pick out without perfect dark conditions, whereas 0 matches the top-tier stars in shine. The proof in visuals is striking. Envision a graph plotting usual comet paths over years, points dotted haphazardly like scattered rain spots on a sidewalk. Now zoom to 2025. 7 points huddled close, resembling a spill of coins from a pocket. The anomaly hits you right away. Normally, hobbyist stargazers chase elusive targets for weeks to snap a decent shot. This time, options abound. Online communities for astrophotos are alive with shots of comet trails crossing the same sky section. Platforms light up with clips capturing what resembles a synchronized dance among the stars. But that's where things get really captivating in our probe. As these 7 comets follow their expected paths, another entity lurks in the void amid worlds. 3I Atlas, the 3rd verified interstellar visitor spotted in our solar system. In contrast to our comet entourage, this one didn't originate locally. It coalesced near a foreign sun in some other setup, and now it's cutting through our turf on a single hyperbolic path. The synchronization sparks queries that haunt experts' sleepless hours. Is it mere luck that our oddest comet-packed year lately overlaps with an out-of-town guest's arrival? Or might intent lurk beneath the surface? As we proceed through this inquiry, we'll draw a firm line between hard data and conjecture. Orbital stats, sighting records, and luminosity figures, those hold up solid. When we wander into unproven territory, we'll flag it plainly as speculation. This isn't agenda-driven hype. It's tracing clues to their source. Our benchmark stays straightforward yet tough. If 3I Atlas ties into this 7-comet cluster somehow, that link ought to show clear traces. Time overlaps defying random odds, path links hinting at design over chance, tangible effects we can track and confirm. No chasing whispers or loose ends needing stretchy explanations. We're after solid, measurable proof that'd sway even the biggest doubters. The sort that elevates guesswork to accepted truth. The implications of this probe reach well beyond mere scholarly interest. Should these 7 comets have converged on their own, guided solely by the unyielding calculations of orbital dynamics and the serendipitous finds of monitoring scopes, we'd be observing an extraordinary yet entirely ordinary astronomical alignment. The cosmos, after all, is immense enough to occasionally deliver groupings that seem significant without any deeper intent. Yet, if an outside factor, be it gravitational pull, electromagnetic effects, or an unknown element, has steered these bodies into a timed convergence, then we're confronting signs of influences acting on dimensions we scarcely grasp. Influences that might fundamentally alter our grasp of celestial motion. Ponder the consequences. In a solar system ruled by reliable physical principles, no 7 comets align by accident. Each path narrates a history. Each course bears traces of the energies that molded it. If an unseen hand directed these trajectories, those traces ought to be traceable. The extrasolar intruder introduces yet more enigma. Oumuamua bears frozen water and debris born in the crucible of a far-off sun, tempered by interstellar rays over eons of travel. Its makeup offers insights into world-building in alien systems. Its conduct nearing our star shows how foreign substances react to solar warmth. But suppose its entry wasn't purely haphazard? Suppose the very power that might have rallied 7 native comets also directed this outsider to our realm at just the opportune instant? Inquiries branch out endlessly, like intricate patterns, with each resolution birthing fresh riddles. How might we spot such meddling? What sort of process could span interstellar voids to align bodies so exactly? And should such alignment prove feasible, what revelations does that offer about the essence of our stellar surroundings? As we gear up to scrutinize each of these odd septet of comets, keep in mind that the heavens seldom yield their truths without effort. All progress stems from an anomaly that defies norms. All advances ignite from queries into why reality strays from simplicity. The cluster has made its entrance, bringing queries that could upend our core beliefs about solar system operations. Yet before diving deeper, we must acquaint ourselves with these 7 arrivals and discern what sets each apart. Random chance or deliberate link. The proof is ready, and it's moment to begin assessing. Part 2. Introducing the cluster's members. We'll profile our 7 guests one by one, since each holds its distinct tale of detection and stellar voyage. Imagine this as an assembly where every participant claims innocence, yet they've all gathered at the identical event site. Pan-STARRS claims the spotlight as our inaugural and most luminous star. Unearthed by the Panoramic Survey Telescope and Rapid Response System, a Hawaii-rooted skywatch that has transformed comet detection, this body is set to become visible to the unaided eye for viewers in the northern skies. The viewing period runs from late March to May 2025, affording extended opportunities to track its inbound path. Pan-STARRS captivates not only for its luminosity prospects, but for its flight configuration. The object's route schemes near Earth's orbital path, rendering it straightforward to spot from inhabited regions. To those hunting for designs, this ease of access seems suspiciously handy. Almost too neat for an entity purportedly drifting in from the Oort cloud's fringes without purpose. Swan unfolds a contrasting tale of revelation. The Solar Wind Anisotropy spacecraft, built to probe solar wind flows, unexpectedly turned comet spotter when its hydrogen sensors picked up the signature shimmer of cometary halos. Swan detections frequently pop up abruptly in the records, their hydrogen outflows signaling arrival ahead of visual confirmation. This hydrogen marker reveals key details on Swan's vigor. Diverging from inert chunks that flare only under solar thaw, Swan was venting gases upon detection, perhaps for months or longer, forming the gaseous sheath that exposed its whereabouts. For a body on a purportedly erratic route, it arrives remarkably primed for its solar debut. Stereo delivers arguably the most gripping origin saga. Solar monitoring probes placed to track our sun's outbursts glimpsed this comet plunging sunward in their side views. Stereo finds frequently turn into reckless sun skimmers, hurtling so near the star that they shatter in dazzling displays or re-emerge transformed by the ordeal. The schedule in this case warrants close scrutiny. The timing of Stereo's approach aligns with a phase of intense solar activity, during which our sun's magnetic field churns with unusual volatility. Is this mere chance? Or does the peak of the solar cycle somehow foster an environment that pulls in bodies from the distant reaches of the solar system? The alignment strikes as far too precise to dismiss outright. Atlas K1 bears the burden of both astronomical excitement and letdown. Upon initial detection by the Asteroid Terrestrial Impact Last Alert System, projections of its luminosity hinted at it becoming one of the brightest comets witnessed in generations. In truth, though, the outcome fell short of those hopes. Observers will probably need binoculars or a modest telescope to appreciate Atlas K1 fully. Yet what raises eyebrows about Atlas K1 in this inquiry is its detection timing, which slots it right into the cluster's schedule. Still, its trajectory indicates it's been tracing this route for millennia. So why has it surfaced precisely now? Why in this particular year, amid a rush of 6 additional comets sharing the same viewing slot? Atlas G3 hails from the identical observational lineage as its counterpart K1, spotted by the same telescope array in Hawaii that's grown exceptionally adept at pinpointing risky near-Earth objects. Functioning as a stellar sentinel, the Atlas project sweeps the observable heavens every couple of nights, seeking out any shifts amid the fixed starfield. What unsettles meticulous skywatchers is the surge in recent comet finds linked to Atlas efforts. Not due to any shortcomings in the setup. On the contrary, Atlas embodies state-of-the-art tech for spotting asteroids and comets. However, when one detection network uncovers several elements of an odd grouping, intriguing trends surface that call for scrutiny. Comet Lemon introduces a distinct background to this celestial assembly. Since the 1990s, the Catalina Sky Survey outpost atop Mount Lemmon in Arizona has pursued near-Earth targets, building one of the richest archives of minor solar system entities ever assembled. Findings from Lemon Command Respect, backed by years of meticulous monitoring and trajectory calculations. Expectations for Lemon's appearance stay subdued, probably best seen through binoculars, but its spot in the cluster lineup is exactly what piques curiosity. It emerges smack in the center of the bunch, neither at the forefront nor the rear, holding its place with a geometric exactness that defies simple chance in orbital dynamics. NE8 completes our group of 7 with a dash of poignant backstory. The Near-Earth Asteroid Tracking Initiative wrapped up in 2007, yet comets it identified in its heyday keep showing up right on cue, adhering to paths mapped out long before. NEAT stands as a testament to methodical celestial sweeps, showing how steady vigilance yields results over time. What elevates NE8's role in this cluster is the lag between its spotting and appearance. This visitor has been monitored for more than 15 years, its course fine-tuned via countless measurements. There's zero doubt about its route or schedule. NEAT was destined to reach us in 2025 no matter what. The real puzzle is its companionship with 6 others. Mapping the trajectories of all 7 onto one chart reveals the bunching beyond question. These aren't fresh 2025 finds just happening to shine now. They're comets unearthed over various years through diverse programs and techniques, all funneling into this tight temporal slot. The range of detection origins amplifies the oddity of their synchronization. From hydrogen spectra, sun-watching campaigns, rock-hunting missions, to focused comet searches, each avenue supplied a fragment of this enigma. It's almost like the cosmos intentionally doled out hints via assorted tools to guarantee we'd spot the arrangement. Ponder the raw odds against it. Comet sightings typically scatter haphazardly through the years, with groupings seldom topping 2 or 3. A septet converging within mere months marks a glaring anomaly begging for answers. And yet, they persist, each locked into courses dictated solely by gravity's unyielding rules. No wiggle room, no space for speculation. These journeys kicked off eons ago, as our 7 guests embarked on their drawn-out plunge sunward. The core riddle nagging every diligent watcher boils down to this. What initiated these routes with such striking harmony? What influence, spanning immense voids and epochs in the solar system's fringes, could steer 7 distinct entities to simultaneous debuts? We're not claiming orchestration here, just recording the anomaly that renders such a notion ripe for exploration. For although every comet obeys the straightforward physics of movement on its own, Together, their actions hint at something more. This phenomenon goes far beyond mere chance. Yet before we can explore any ties to our cosmic wanderer from afar, it's essential to grasp why such a concentration of activity feels so out of the ordinary to seasoned stargazers. That means delving into the typical patterns of comet sightings in an average year. Section 3. Why this stands out as exceptional. Step into a standard planetarium during a routine year and inquire about comets you can spot with the unaided eye. The expert there might let out a weary breath, consult their records, and mention perhaps a single faint blip that demands a quality scope and clear, unlit nights. If fortune smiles on you, there could be a comet visible through binoculars that hobbyists are diligently following. In most years, not even one comet shines bright enough for bare-eyed viewing to light up our nights. That's the everyday truth of observing these icy visitors. Waiting games filled with letdowns, punctuated by rare payoffs that call for dedicated gear to truly enjoy. The everyday crowd stays happily oblivious to those pale, nebulous specks that thrill dedicated skywatchers. For the masses, comets live on mainly in old tales and blockbuster flicks about doomsday. But 2025 disrupts this routine with the force of an astronomical battering ram. No fewer than 7 significant comets appearing in quick succession. Several ones vivid enough to capture on everyday phone cameras. A handful hitting binocular range, including at least one that's shaping up as a real showstopper for backyard viewers. To gauge just how rare this bunching truly is, let's break down the stats behind comet finds and their glow. Today's automated sky patrols have transformed how we spot far-off wanderers. Still, they've not altered the core science dictating when these travelers flare up enough to catch our gaze. From Haleakala on Maui, the Pan-STAR setup sweeps the full observable heavens every couple of evenings. Arizona's Catalina program methodically charts varied sky sections with exacting care. Up in orbit, NEOWISE picks out thermal traces from bodies that evade Earthbound detectors. These efforts uncover scores of fresh comets and rocks annually, though the bulk stay locked in telescope view only. Just a minuscule share ever amps up to draw widespread notice. On average, expect 0 to a single comet per year hitting naked eye levels, plus maybe 2 or 3 more that keen amateurs can chase. But fancier spotting tech doesn't account for 2025's bounty. Sure, these scopes unearth more stuff in general, yet the share turning into standout comets holds steady against past trends. Enhanced tools expose farther, dimmer targets. They can't conjure dazzling displays from nothing. The crucial point: what makes a comet shine stems from traits surveys can't tweak: its scale, makeup, and solar proximity at perihelion. Those traits got set eons back, as gravity's tugs first steered them sunward. Current patrols just flag inbound guests that fate had already booked. This nuance is vital for our probe. Where better surveys the culprit for the cluster, we'd anticipate echoes in nearby years as gear evolved. Instead, 2025 looms as a lone spike in solar system buzz. And speaking of scrutiny, it's worth double-checking claims of brilliance, since news outlets sometimes hype average sights into letdowns for newbie watchers. Remember, the magnitude system flips intuition. Lower figures mean stronger light. At magnitude 6, you're at the edge of what the eye can pick out in ideal, pitch-black conditions. City dwellers often need aids for anything below 4. Forecasting a comet's peak is tricky. Outbursts hinge on makeup and sun's warmth in unpredictable ways. Some surge wildly if icy bits sublimate fast, while others fizzle under dusty shells that choke the jets. Even with that variability, pros hone sharp instincts on which ones to watch. So when old-timers voice astonishment over 2025's packed roster, it echoes lifetimes of scanning barren vaults for the unworthy faint. Layer on the sun's peak activity, which weaves extra intrigue into our quirky year. Our star pulses through an 11-year rhythm, swinging from calm spells dotted with sparse spots to stormy eras rife with blasts and ejections from its corona. 2025 aligns with that high point. When the sun's field hits its turbulence in space, weather plays a significant role. Intense solar flares can profoundly alter the dynamics of a comet's tail, leading to striking detachment incidents and atypical formations that give even faint comets a more vibrant look than their inherent luminosity would indicate. Heightened solar wind at peak activity further boosts the ion tails of these celestial bodies, which could render our 7 incoming travelers more visually striking compared to their showings during quieter solar phases. However, solar outbursts don't generate comets themselves. They merely modify how these visitors present themselves once they enter the inner solar system. These particular objects were already on course for 2025 rendezvous, irrespective of fluctuations in solar behavior. Peak solar output may enhance their observational appeal, but it fails to account for the decision of 7 distinct comets to make their solar system appearances in this specific year. This brings us to the realm of human cognition, which introduces layers of complexity to dispassionate evaluation. Our minds developed to spot patterns, including in chaotic datasets, as overlooking real ones might have spelled disaster in prehistoric settings. While this instinct proves invaluable in various scenarios, it often tricks us into seeing purposeful links amid pure chance. Bunches of occurrences inevitably draw scrutiny and call for interpretation. When several uncommon phenomena stack up in close proximity, we tend to hunt for root causes instead of chalking it up to serendipitous alignment. Such mental shortcuts intensify when the happenings appear deliberate or orchestrated. The influx of 7 comets sets off precisely this urge to connect dots. Having 7 entities converge over a span of mere months strikes us as too structured to be haphazard. Our gut feelings about odds push back against viewing such a grouping as simple luck. Still, solid probability studies show that seeming groupings pop up frequently in purely stochastic processes. Toss a coin repeatedly, and sooner or later, you'll witness extended runs of heads or tails that seem outrageous yet align with expected math. People's intuition resists embracing these groupings as innate outcomes of chance. For our probe, the key lies in distinguishing true outliers from groupings that intrigue our pattern-hungry brains yet stay inside typical fluctuations. Establishing quantifiable benchmarks for when a trend surpasses plausible fluke territory is essential. That's precisely why meticulous examination of orbits holds such importance. Should these 7 comets exhibit faint shared pulls from gravity, overlapping origins, or time disruptions beyond random likelihood, we'd have basis to infer some directing influence. If the bunching boils down to the sort of illusory structure that arises spontaneously in massive datasets, then chance stands as the simplest account. Standards for proof must remain suitably rigorous. Bold assertions demand robust backing, and proposing that an external agent guided 7 comets into aligned approaches absolutely counts as bold. We require telltale signs robust enough to sway doubtful experts who routinely dismiss false links. Yet as we gear up to explore possible drivers of such alignment, it's useful to recall that the cosmos sometimes delivers authentic shocks that upend our views on natural order. At times, the unlikely account proves accurate, and at others, apparent flukes conceal profound realities, ready for thorough scrutiny to uncover. The cluster exists. The schedule is odd, and the inquiries insist on resolution. But what sort of influence might align entities over such immense spans of space and duration? And might our extrasolar guests supply the key to unraveling this stellar enigma? Section 4. The Hidden Influencer. When stargazers face baffling trends, they turn to 2 core forces, gravity and electromagnetism. These principles control nearly all motion across the void, from world paths to the antics of ionized bits in comet streams. If an entity is nudging 7 comets toward timed arrivals, it has to work via one of these channels. We'll begin with gravity, the unchallenged director of solar system dances. Any mass-bearing body curves space-time nearby, forging the unseen framework that steers planet loops and comet paths. Gravity functions over boundless reaches with exacting math that lets sky watchers forecast heavenly happenings hundreds of years ahead. But consider the key drawback: gravity's inherent feebleness. Substantial bulk is needed to yield detectable impacts over planetary gaps. The Sun, with its commanding pull, dictates the overall flow of solar system dynamics. Jupiter, a mere 1/1000th of the Sun's heft, nonetheless exerts sway on rocks and icy wanderers via its pull. To orchestrate the synchronized entry of comets, an entity would require the heft of a substantial planet. This isn't about gradual tugs building up across eons. Instead, it's the sort of pull that orbital analysts would spot right away when examining these bodies. The equations leave no room for error. A comet's path, its tilt, elongation, and schedule, bears the marks of every gravitational tug it's endured along the way. Such traces are impossible to conceal or mask. Should a hefty body be guiding our 7 arrivals, its traces would stand out plainly in their trajectories. Jupiter offers a prime example of genuine gravitational guidance. The massive world has sculpted voids in the asteroid zone, snagged clusters of Trojan asteroids trailing its course, and rerouted numerous comets via close gravitational brushes. Scientists can quantify these impacts accurately, pinpoint the driving forces, and forecast upcoming encounters reliably. This provides a blueprint for spotting concealed guidance. If an unidentified large body has swayed our 7-comet group, we'd detect uniform trajectory disturbances, matching gravitational imprints, or aligned shifts indicating a unified origin. The lack of these markers would solidly dismiss gravitational orchestration. Electromagnetic influences present an alternative, yet similarly limited, option. Comets hold electrical charges as sunlight breaks down their gas envelopes, with flowing particles reacting to magnetic fields in detectable fashions. The solar wind, that steady outflow of energized matter from our sun, molds comet ion streams and triggers striking separations amid magnetic upheavals. However, these forces operate far unlike gravity. They impact tails and atmospheres without much shifting core paths. A comet streamer may coil and shift due to solar magnetic fluctuations, yet the nucleus persists on its gravity-set route with unyielding accuracy. The notion that magnetic fields could direct 7 comets toward timed convergences runs into fundamental physical barriers. Such direction would demand field intensities vastly beyond solar system norms, with power needs surpassing the sun's total output. These are forces confined to the environs of neutron stars and black holes. Furthermore, magnetic impacts yield distinct patterns in comet light signatures and tail dynamics that couldn't be obscured. If intense fields were directing our 7 guests, observatories tracking them would pick up the obvious indicators at once. This leads to the standards that distinguish conjecture from empirical inquiry. Authentic guidance, be it gravitational or magnetic, has to yield detectable proof that withstands close scrutiny. We require overlapping trajectory features signaling joint effects, steady disturbances surpassing observational limits, aligned irregularities unexplained by solo development. Now, let's examine our 7 comet players: Pan-STARRS, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and NEAT. Using these benchmarks methodically, do they exhibit trajectory traits hinting at unified external forces beyond the solar system's routine gravity? The initial findings disappoint those chasing conspiracies, but comfort standard astrophysics. Every comet traces a path aligning with solar progression under familiar pulls. Their origins, tilts, and schedules reveal no signs of orchestration past chance groupings from random chance. Pan-STARRS comes from a distinct angle compared to Swan. Stereo's sun-skimming arc shares nothing with Atlas K1's farther-flung route. Lemon and NEAT sprang from varied outer solar realms and took separate trails to their present spots. Were a secret guide aligning these entries, we'd anticipate faint yet quantifiable links in their path histories, overlapping points in their routes, alike disturbances implying common tugs, or schedule ties stretching beyond mere luck. Rather, we observe 7 distinct entities on 7 separate courses, aligning merely by arriving at maximum visibility around the same broad window. Their paths recount lone voyages from varied launches, molded by the steady hand of solar gravity plus sporadic planetary brushes. This doesn't fully exclude outside alignment, but it elevates the proof threshold considerably. Moreover, if any force is disrupting these comets, it must work via processes so delicate that they evade spotting by today's telescopes and surveys. The more straightforward idea, random grouping amplified by better detection tools, aligns better with the data we have. Yet, our probe shifts in a captivating direction when we examine 3I/Atlas as a possible orchestrator. In contrast to the 7 classic comets, This outsider from beyond our system has no duty to obey the pull of local gravity, with its hyperbolic path and outside provenance turning it into a true alien player in our stellar backyard. Might an extraterrestrial body, even with its modest size, subtly alter the schedule or actions of native comets in ways beyond our grasp? This query challenges the edges of standard physics, yet warrants thoughtful exploration amid the odd setup. 3i/Atlas's shortcomings as a guide become clear right away. Its calculated weight is nowhere near that of a planet, rendering any pull insignificant. Its swift trip across the solar system offers scant opportunity for minor tugs to build up. Its route avoids direct crossings with those 7 familiar comets, eliminating chances for nearby brushes that could yield noticeable impacts. Still, the sync timing bothers skeptics who favor a cosmos without eerie links. An interstellar guest showing up amid our system's busiest comet season in ages seems far too neat for mere luck. Though 3i/Atlas may not tweak comet paths outright, might its appearance tie into factors that boost such groupings? This idea ventures into compelling guesswork while staying grounded in what we observe. We're not suggesting hidden forces or wild theories that defy proven principles. Instead, we're wondering if an interstellar arrival could overlap with everyday dynamics that ramp up comet visibility or outbursts. Perhaps 3i/Atlas acts more as a signpost than a driver, like a stellar barometer signaling time's ripe for comet finds. It's possible that such wanderers tend to show during eras of heightened outer system turbulence, spurring more comets to head inward toward the sun. These notions call for rigorous study over offhand musings, but they show how apparent orchestration could arise from vast natural forces we're just starting to fathom. The cosmos has stunned us in the past with faint ties that once appeared implausible. As we gear up to scrutinize this interstellar enigma more closely, keep in mind that groundbreaking insights often spring from data that resists tidy theories. At times, what seems outlandish just needs sharper tools and deeper review to uncover its reality. Part 5. Raising the Flag. The signal we're raising isn't a frantic cry of approaching catastrophe. Rather, it's the steady call of scholarly intrigue facing a puzzling trend. Picture it as a stellar alert system, not a blaring evacuation horn. An oddity is unfolding in our skyward domain, and sound inquiry requires we probe it thoroughly prior to any verdicts. The year 2025 holds the potential for a heavenly display that turns armchair skywatchers into fervent comet chasers. Several vivid bodies sprouting dazzling tails all at once, imaging chances that might come around only every few decades. Online platforms buzzing with sped-up clips of sky wanderers streaking through constellations like a scripted dance. The show itself carries zero risk. Comets are inherently delicate entities, scattered clumps of frozen water, grit, and carbon-based stuff that scarcely cling together under their feeble self-pull. As sunlight turns them into the stunning sights that grip the public's fancy, we're seeing them dismantle bit by bit, losing bits that won't return. Even the tightest flybys among our 7 comet parade stay at safe removes by cosmic measures. Pan-Star S's closest swing keeps it far outside the moon's path, while Swan and Soho trace routes that threaten neither Earth nor any key celestial feature. These are mere overhead passes, not crash trajectories. The real unease stems from the innate detection circuits etched into our minds by evolution for staying alive. When several anomalies bunch up, we naturally hunt for root reasons instead of shrugging off the overlap as fluke. This instinct aided our forebears in spotting grouped dangers out in the wild. But today's people wield that identical trend spotting. Our innate predisposition draws us toward grand cosmic occurrences that unfold on timescales far beyond our everyday grasp. The sight of 7 comets appearing at once sparks instant curiosity about their origin. What power might orchestrate such exactness over immense cosmic expanses? Why at this moment? And why as a group? These inquiries gain even more urgency when linked to the arrival of 3i/Atlas, that extraterrestrial wanderer whose schedule feels suspiciously timely to dismiss as mere chance. The storyline almost composes itself. Extraterrestrial scout lands. Comet cluster trails behind. Clearly, an event of significance unfolds, urging swift scrutiny. Online platforms boost this storyline since enigmas and possible plots fuel the interaction stats that power their business models. Clips hinting at secret ties among sky phenomena garner far more attention than precise breakdowns of gravitational paths and chance likelihoods. The tale expands with each retelling, nourished by humanity's shared desire for purpose amid a seemingly chaotic cosmos. This is precisely why our principle of verification holds such importance. Any daring assertion needs thorough validation against proven scientific principles and empirical records. Conjecture is permissible, even welcomed, yet it demands explicit tagging and adherence to fitting proof thresholds. The allure of drama cannot excuse presenting baseless ideas as proven truths. We must repeatedly highlight the gap between display and causation. Stunning visuals do not imply orchestration. Thrilling displays do not suggest manipulation. Striking displays do not indicate peril. The cosmos routinely yields natural spectacles that surpass our artistic ideals without needing outlandish rationales. Reflect on how the heightened solar dynamics of 2025 will intensify the spectacle of this comet procession. The solar peak triggers repeated plasma bursts and swift charged particle flows, which can profoundly alter comet tail formations. During intense solar flares, ion tails could span several degrees of the heavens. Tail detachment incidents might mimic comets fragmenting as if directed. Such occurrences will produce stunning images and footage that appear to reveal unified actions among our 7 guests. Digital networks will overflow with visuals seeming to capture aligned tail shifts, concurrent flares in brightness, and further oddities implying outside direction. In truth, the explanation proves far simpler, yet equally captivating. Every comet reacts on its own to the identical solar conditions, yielding an illusion of unity via uniform exposure to ramped-up solar output. Picture observing 7 separate wind indicators all aligning in a gale, a unified reaction to a shared force, not proof of deliberate oversight. This alignment with solar peak introduces yet another dimension to our probe. What links our exceptional comet season to the height of solar vigor? Does a tie exist between sunspot patterns and the frequency of comets venturing inward from the system's fringes? Might gravity or magnetic forces tied to solar highs subtly shape when comets enter view? These probes venture into hypothetical realms, but stay anchored in observable realities. Solar fluctuations adhere to thoroughly recorded patterns that align with diverse space weather impacts. Should solar peaks boost the odds of spotting or welcoming comets? Patterns in archives covering several cycles ought to reveal it. The inquiry structure we're building insists on ongoing alertness to selective perception biases, the impulse to view unclear data as backing favored views. Upon noticing peculiar tail patterns, our initial step should involve scanning for solar flare influences, rather than leaping to intricate control schemes. For sudden luminosity spikes, we ought to assess the comet's makeup and heat from the sun over presuming outside causes. For path deviations, confirm data reliability and review standard disturbance factors prior to suggesting mysterious agents. Such a methodical mindset does not stifle awe or curb valid hypothesizing. It merely guarantees our appreciation for the unknown aligns with real findings, not hopeful fantasies. The cosmos offers ample true enigmas without us fabricating extras. This grouping of 7 comets marks a valid improbable occurrence warranting in-depth review of possible root factors. Such groupings arise seldom, making detailed exploration of hidden drivers worthwhile. If our examination uncovers only serendipitous alignment boosted by better detection tools, that insight alone enriches our grasp of solar system patterns. Yet should we uncover real links surpassing chance, like orbital links, arrival harmonies, or conduct irregularities that if multiple pointers align to shared origins, we've pinpointed a factor that might fundamentally alter our view of solar system dynamics. The arrival of 3 such atlas entities in this atypical period introduces an unpredictable twist, turning what was once a mere statistical oddity into a possibly deep enigma. Interstellar intruders show up roughly every 10 years, so their scheduling holds real weight instead of just novelty. We aren't suggesting that these 3 Atlas instances triggered or orchestrated the cluster of 7 comets. Instead, We're stressing that this overlap warrants scrutiny, not offhand rejection. Even without a straight causal link, the association could uncover subtle ties that shed light on overlooked features of solar system patterns. Our duty goes further than steering clear of baseless alerts. It includes guarding against overlooking true indicators while we strive to dismantle baseless notions. Scientific history brims with cases where seemingly absurd concepts gain validation via thorough probing and building proof. The key lies in upholding balanced doubt while staying receptive to data that challenges standard views. We require strict criteria for assessing bold assertions without getting so inflexible that we dismiss compelling proof when it surfaces. As we gear up to scrutinize our cosmic newcomer closely, keep in mind that the deepest breakthroughs frequently arise from probes sparked by basic inquiries into quirky trends. At times, the cosmos seeks to impart fresh knowledge, and occasionally that insight comes wrapped in the guise of chance. The cluster has triggered its alert, and we're countering with the instruments of empirical study, not knee-jerk alarm. No matter the revelations ahead, they'll surface through precise gauging and dissection, not guesswork or presupposition. Yet before anything else, we must grasp our main contender, the extraterrestrial intruder, whose arrival has sparked countless queries. Section 6. The extraterrestrial intruder. 3. Atlas marks the third verified interstellar body to traverse our solar system. A stellar drifter born near a foreign sun, now executing a singular hyperbolic pass through our starry domain. In contrast to all prior items we've covered, this guest lacks any native origin papers. It's truly otherworldly in the purest meaning. The weight of this difference is immense. Each comet in our seven-strong group sprang from the pull of our solar system's gravity, shaped from the identical ancient stuff that formed worlds and satellites some 4.5 billion years back. 3I, Atlas, however, bears frost and grit that solidified near a separate sun in a distinct cosmic cradle, amid circumstances beyond our full grasp. Picture it as a note in a vessel from distant lands, but one that crossed not waters, but the immense void spanning star clusters. The trek probably spanned eons, as our guest floated across the almost absolute emptiness of interstar voids, pelted by galactic rays and slowly gathering the molecular marks of its grand odyssey. Crucially for our probe, 3I/Atlas presents zero impact risk to our planet. Its course steers clear of all key worlds, tracing a hyperbolic route that will ultimately hurl it back into the interstellar expanse, gone forever. This amounts to a scouting venture, not a takeover, presuming such notions apply to what could just be a roving slab of primordial frost. The comet-style traits of 3 Atlas enrich its narrative with added intricacy. Remote from the sun, where chills ought to lock ice in place, this body has formed a noticeable envelope and streamer. Sunlight at those ranges shouldn't suffice to spark the gas release that produces evident comet signs. Still, sightings plainly reveal the hazy look that sets lively comets apart from dead rocks. This early vigor hints at either a quirky makeup, maybe holding ultra-sensitive substances that turn to gas in frigid settings, or an inner warmth generator fueling emissions apart from solar influence. Each option dangles intriguing hints about the environment in the star realm where 3I/Atlas took shape. The buzz in science around any such outsider arises from its rare role as a raw glimpse into another system's makeup. Each observation we take, spectrum scans of its makeup, light curve watches of its glow shifts, position logs of its exact path, yields insights into star-building mechanisms outside our sun's domain. But this account zeroes in on a separate puzzle. Might this cosmic outsider in some way be conned? Is there a link between the peculiar timing of our 7-comet cluster and this interstellar intruder? While the overlap could simply be happenstance, the potential ramifications warrant thorough scrutiny instead of offhand rejection. Should a real tie bind the 3I Atlas to our 7 familiar comets, it would reveal itself via detectable markers that hold up under intense examination, temporal alignments defying mere chance, paths in space hinting at deeper ties, and odd patterns in motion suggesting common drivers over separate paths. Lacking those indicators would firmly rule out any bond, reducing the event to a curious but insignificant fluke. On the flip side, Evident links would raise deep inquiries into dynamics spanning vast distances beyond our grasp. Imagine uncovering how an outsider from the stars could subtly alter the actions of our solar system's inhabitants. That kind of influence would point to interplay mechanisms more intricate and extensive than today's theories allow. It might even suggest interstellar links that go beyond the basic pulls of gravity we know. Without delving into wild theories, the synced arrival of 3I Atlas amid our rare comet flurry calls for close study. Such cosmic wanderers show up infrequently, maybe every 10 years, per recent sightings. Their appearances ought to scatter randomly through time, unrelated to happenings within our system. But now, one drops in right during the oddest comet season we've seen lately. The odds are easy to crunch. If these are unrelated phenomena, their joint timing should be exceptionally uncommon. The rarer each part, the more this overlap raises eyebrows. Naturally, alignment doesn't prove cause and effect, nor does odd scheduling offer ironclad proof of interplay, yet it does merit the in-depth probe we're pursuing. If the cosmos is hinting at hidden ties between far-off travelers and nearby bodies, we must tune in sharply to catch the message. Expectations for 3I Atlas's glow need tempering to sidestep letdowns ahead. Unlike the dazzling potentials in our 7-comet group, this star-hopping guest will probably stay visible only through scopes during its trek. Its value to science dwarfs any show it puts on for backyard stargazers. Experts and hobbyists globally are teaming up on watch efforts to squeeze every bit of insight from 3I Atlas's short stay. Each ray we capture from it holds priceless details on another star's realm. This is our sole shot at probing this exact caller. Its escape-like path guarantees a single pass, with 0 comebacks. These watch efforts also give us prime chances to spot any bonds with the 7-comet cluster. If mutual quirks appear, like matching fades and shine, linked tail traits, or schedules beyond luck, they'd surface from vigilant tracking of all 8 at once. The trick is sorting true patterns from illusions that crop up when minds sift through messy data. Our pattern-spotting instincts, honed for finding signals in chaos, can sometimes fabricate order out of nothing, especially when we're eager for discoveries. That's why we keep raw data collection apart from theorizing. Readings on light shifts, path details, or light spectra reflect hard facts. Probing ties among them shifts us to testing ideas, where doubt tempers eagerness. Science's toolkit helps strike that equilibrium. Stats can gauge how likely a link stems from pure randomness versus real ties. Cross-checks by varied teams with diverse tools confirm if patterns endure. Still, even tight checks demand our calls on what evidence backs bold ideas. Claiming a spacefarer sways local comets rates as wildly bold, so it needs rock-solid backing for real debate. As we gear up to dissect 3I Atlas's path features and forecast moves, keep in mind how far-reaching this probe's outcomes could be. Beyond just unraveling an odd happenstance, should real links emerge between these cosmic travelers and the movements within our own solar neighborhood, such a revelation could profoundly reshape our grasp of interactions among star systems over immense cosmic expanses. The cosmos might prove far more linked than present models imply, with faint forces at play on dimensions that outstrip our everyday perceptions. Alternatively, it could merely present a captivating random outlier, challenging our skill in separating true signals from mere chance. Regardless, the truth resides in the observations, and the moment has come to scrutinize this extraterrestrial anomaly with greater precision. The outsider has made its entrance, its narrative etched in the contours of its path. Chapter 7, Path of Mystery. The course traced by 1I/Oumuamua resembles a stellar travel log, chronicling a voyage that originated in the void between stars and will conclude there too. In contrast to the oval paths that bind planets and classic comets in perpetual loops around the sun, this interloper traces a hyperbolic route, the hallmark of something possessing sufficient speed to break free from our solar system's pull indefinitely. Imagine a whip-like arc plunging from the outer reaches toward the sun, arcing tightly around our central star, then surging away into the interstellar gloom. No encores, no extra opportunities for study. 1I/Oumuamua claims a single sweep through our cosmic backyard, and we're observing it unfold live. Its orbital parameters weave an engaging tale of beginnings and endpoints. The intruder hails from a bearing aligned somewhat with the Perseus constellation. While the emptiness of interstellar realms offers no markers for its precise origin, the hyperbolic surplus speed, the velocity it retains post-solar escape, points to a trek lasting hundreds of thousands of years from the closest potential host stars. What renders this path especially captivating is its tilt compared to the ecliptic, the level plane housing planetary tracks and much of the solar system's rubble. Rather than barreling in steeply from above or below the disk of worlds, Oumuamua enters at a gentle slant. This near-planar alignment positions the body nearer to the routes frequented by our 7 comet group members during their sunward jaunts. That tilt merits close scrutiny, as it impacts the odds of gravitational tugs with intersolar objects. An arrival from elevated galactic heights would skim our system with scant chance to perturb resident motions. Yet Oumuamua's subtler angle sustains its presence amid the broader zone of world and comet circuits for a prolonged stretch. This implies no imminent brushes, of course. The gaps remain vast, spanning astronomical units well outside zones of meaningful pull. Still, it signifies that Oumuamua lingers for months in the broad spatial domain where our 7 standard comets pursue their solar dips. The backward direction of Oumuamua's travel introduces further spatial intricacy. Whereas nearly all solar residents circle the sun aligned with planetary spin, this stellar guest arrives head-on from the reverse. Such opposing flow generates approach speeds surpassing those in typical solar tussles. Swift closing rates generally weaken pulls, since quick transients limit exposure to mutual fields. Were Oumuamua somehow nudging the orbits of legacy comets, its reverse heading would counteract that by shortening any fleeting overlaps. These path traits set key limits on our probe. Whatever sway Oumuamua holds over the 7-comet cluster would demand indirect channels, bypassing needs for proximity or drawn-out pulls. Standard orbital nudges via classic mechanics seem ever more improbable under this spatial lens. Yet paths by themselves don't rule out every tie. Alignments and timing between Oumuamua's pivotal path milestones and odd shifts in our comet ensemble might uncover effects beyond basic force math. Reflect on the import of crossing points, where Oumuamua's line intersects the ecliptic. These intersections mark instants of nearest proximity to the zones held by conventional comets and their dust wakes. Should any exchanges arise between outsider and locals, these nodal transits offer prime windows. The rising and falling nodes of Oumuamua fall on precise dates, computable through astronomical precision. If these dates correlate with unusual activity in our 7-comet swarm, brightness outbursts, tail anomalies, or orbital perturbations, such correlation would constitute genuine evidence for some form of connection. The challenge lies in defining what constitutes unusual activity in a context where comet behavior naturally includes considerable variation and unpredictability. Brightness fluctuations, tail development, and even minor orbital changes occur routinely as comets respond to solar heating and outgassing forces. The bar for evidence must be set high enough to exclude normal comet behavior from consideration. Statistical analysis provides tools for addressing this challenge objectively. If we monitor our 7 traditional comets continuously and catalog all instances of brightness changes, tail events, or other notable behavior, we can then test whether such events cluster around 3 Atlas's key orbital dates more frequently than random chance would predict. The null hypothesis that 3I Atlas and the 7-comet swarm are unrelated predicts that unusual events should be distributed randomly across time uncorrelated with the interstellar visitor's orbital milestones. Any significant deviation from random distribution would argue for some form of connection even if the mechanism remains unclear. But we must also guard against selection bias. The tendency to focus on apparent correlations while ignoring instances where expected patterns fail to appear. A rigorous investigation requires tracking all potentially relevant events, not just those that seem to support preferred conclusions. The orbital evolution of 3I provides additional opportunities for testing potential connections. As the object approaches perihelion, Solar heating should drive increased outgassing activity that might trigger corresponding responses in other objects if some form of communication or coordination mechanism exists. The predicted brightness curve for 3I Atlas shows steady brightening as it approaches the Sun, potentially punctuated by sudden outbursts if volatile materials vaporize rapidly or if internal structures fragment under thermal stress. Each of these events occurs at predictable times and locations along the orbital path. If the 7-comet swarm somehow responds to 3I Atlas's activity, those responses should occur at times that correlate with the interstellar visitor's predicted brightening events. The tighter the temporal correlation, the stronger the evidence for genuine connection rather than coincidental timing. However, we must also consider the possibility that apparent correlations result from shared responses to common external influences rather than direct interaction between objects. Solar activity, interplanetary magnetic field variations, or other space weather phenomena might affect all comets simultaneously, creating the appearance of coordination without requiring direct communication between objects. This solar influence hypothesis predicts that any correlated behavior should be traceable to specific space weather events, solar flares, coronal mass ejections, or high-speed particle streams that interact with comet atmospheres in measurable ways. The presence of such solar triggers would argue against exotic coordination mechanisms in favor of conventional astrophysical processes. The orbital characteristics of 3IA Atlas also constrain the duration of any potential influence on solar system objects. The visitor's hyperbolic trajectory ensures a brief passage through our neighborhood, perhaps 18 months from initial detection to final departure beyond observational reach. This limited interaction time means that any effects on the 7-comet swarm must manifest relatively quickly and be detectable with current instrumentation. Subtle influences that accumulate over decades or centuries would remain invisible during 3I Atlas's brief visit. As we examine the specific predictions for perihelion passage, remember that orbital mechanics operates with clockwork precision regardless of the exotic possibilities we're investigating. 3I Atlas will reach its closest solar approach at a time and location determined by gravitational forces that care nothing for human speculation about alien coordination or interstellar communication. The numbers don't lie and the geometry tells its own story, but whether that story includes connections to our 7-comet swarm remains an open question that perihelion may finally answer. Part 8. What happens at perihelion? Perihelion represents the moment of truth for any comet. The closest approach to our Sun when months or years of gradual approach suddenly accelerate into a crescendo of activity. For 3I Atlas, this milestone carries particular significance because it marks the point where an interstellar visitor experiences the full intensity of our star's radiation and particle output. The physics of perihelio, the actions of 3I Atlas exhibit both expected patterns and striking changes. With its approach toward the Sun, the influx of solar energy grows stronger following the inverse square principle, causing the illumination and thermal output to double every time the separation halves. The frost that endured in solid form over the extended voyage through space starts to sublimate, forming the gaseous and particulate shroud that turns a shadowy, motionless body into a radiant, dynamic comet. Yet the makeup of ice from interstellar origins probably varies from the water-rich blends typical of comets in our solar system. 3I Atlas originated in the distant zones of a different star system, where cooler climates and unique chemical setups may have promoted alternative molecular forms. Dominance by substances like carbon monoxide, carbon dioxide, methane, and rarer compounds could define its structure. Such variations in makeup ought to become evident via spectral examination as it passes perihelion. When heated and energized by sunlight, each type of molecule generates distinct spectral signatures. The light profile from 3I Atlas will basically act as a molecular signature of its formative surroundings, intact after eons of travel between stars. Should our study reveal true links between 3I Atlas and the 7-comet cluster, the closest solar approach offers the prime chance for major discoveries. The extreme warmth from the Sun that fuels maximum comet dynamism could likewise activate any processes that might synchronize actions across several bodies. The indicators to monitor range from faint to vivid. Abrupt surges in luminosity frequently signal the sublimation of highly unstable substances or the uncovering of new icy layers as overlying dust layers wear down. Such flares can amplify a comet's glow by 10 times or greater in mere hours, yielding impressive viewing moments alongside hints about its core makeup and build. Streams of ejecta shooting from particular spots on 3I/Atlas's core might generate uneven propulsion, subtly shifting the object's path. These gravity-defying effects represent established features in conventional comets, yet detecting them in an extrasolar arrival would yield novel understanding of how substances from foreign star systems react to our star's effects. Special focus goes to the evolution of 3I/Atlas's tail formation, as it delivers immediate views of the clash between alien matter and the sun's particle flow. Ion tails arise as solar UV light charges comet vapors, producing ions that flow outward under the sun's magnetic pull. How this ion tail behaves, its extent, direction, and reactions to solar wind shifts will expose the dynamics between vapors from another star system and our sun's emissions. Deviations from patterns in standard comet tails could suggest makeup contrasts that set interstellar stuff apart from native varieties. Dust tails operate under separate rules, molded by light pressure instead of magnetism. The dimensions, spread, and nature of dust grains dictate the extent to which sunlight can push them off straight-line orbits. Bigger grains stick close to their initial routes, whereas tiny specks get swept into broad, arcing appendages spanning wide sky areas. Should 3I/Atlas develop an exceptionally vivid dust tail, it may point to a wealth of small grains highly sensitive to solar light push. On the other hand, splitting apart near perihelion might abruptly unleash vast dust reserves held deep inside the comet's framework. Breakup incidents mark the most intense result of solar proximity. The mix of intense heat, spin-induced strain, and buildup from outgassing volatiles can overwhelm a comet's frail self-gravity. The body shatters, at times dividing into pieces that drift separately along the orbit. For 3I/Atlas, such a split would hold special weight, granting views of inner substances untouched since its creation in a foreign star system. Newly bared faces from the rupture would enable rare spectral probes of untouched extrasolar matter. However, a breakup might also hinder probes into ties with the 7-comet group. Pieces on varied paths could mimic linked motions that aren't real, just from the tangle of following multiple linked items at once. The solar wind conditions around 3I/Atlas's perihelion also introduce an extra factor that might affect both the alien guest and any possible bonds. During solar maximum, heightened particle concentrations, intensified magnetic fields, and recurring coronal mass ejections profoundly influence the dynamics of comet tails. These solar weather phenomena produce stunning optical displays, including tail separations, plasma disruptions, and magnetic reconnection processes that cause tails to contort, buckle, or even detach completely. Although such occurrences happen in isolation around each comet, they arise from identical solar influences, which might give the illusion of synchronized activity without any real linkage. Differentiating true interplay from mere parallel reactions to solar drivers depends on careful examination of timing, accuracy, and spatial geometry. Disruptions in the solar wind expand from the sun at known speeds, arriving at various comet positions at estimable intervals. Should the peculiar actions among our cluster of 7 comets align with incidents involving 3I/Atlas, yet defy explanations tied to solar wind travel lags, this alignment gains notable intrigue. Enthusiast skywatchers across the globe are organizing viewing initiatives to track 3I/Atlas as it nears its closest solar approach, offering widespread monitoring that surpasses the scope of any lone facility. This grassroots effort will yield ongoing brightness profiles, image records of tail evolution, and instant notifications for any intense flares or splitting occurrences. The watching effort also involves expert installations, from orbital instruments and earthbound scopes to dedicated comet tracking programs, all feeding into the deepest probe of an extrasolar wanderer ever conducted. Each captured ray of light delivers invaluable insights into the environments of distant star systems. However, Our probe demands simultaneous scrutiny of the 7 established comets over this time frame, seeking odd patterns that could link to 3I Atlas happenings. Such a side-by-side method aids in separating routine comet fluctuations from possible meaningful ties that surpass chance alignments. The exactness needed to spot faint connections strains modern viewing technologies to their utmost. Subtle shifts in luminosity, small imbalances in tail shapes, or minor trajectory tweaks could offer the sole clues to unusual influences lurking beyond standard sensing limits. With perihelion drawing near, keep in mind that universal physics follows unwavering principles, untouched by our desires for thrilling findings. 3I Atlas will glow brighter, grow tails, and perhaps disintegrate due to its own makeup under solar warmth, rather than any intent to dazzle earthly viewers. Still, amid these inherent mechanisms dwell chances for deep revelations regarding interstellar substances and their reactions in our sun's domain. If those revelations encompass signs of ties to our 7-comet group is a matter yet unresolved, resolvable solely through meticulous watching. The celestial machinery ticks on with unerring rhythm, unmoved by conjecture, yet reliably supplying the evidence to separate fantasy from true insight. Part 9. The Swarm and the Sun. Our sun follows rhythms that outlast human lifespans, swinging between eras of mild tranquility and bursts of intense dynamism like the beat of a stellar timer. The 11-year solar rhythm dictating this pattern crests in 2025, reshaping our central star into a fiercer, more dazzling iteration of its everyday form. Solar maximum delivers a surge of sunspots, those shadowy zones signaling spots where potent magnetic forces pierce the sun's outer layer. These magnetic hotspots hold vast energy reserves that sometimes erupt violently, flinging ionized matter and radiant energy across the solar realm in mere hours or days. For our probe into the 7 comets, this ramped-up solar vigor offers both advantages and hurdles. The denser particle flows and robust magnetic forces at solar peak can greatly heighten comet tail displays, turning ordinary visitors into far more striking sights than in lulls of solar quietude. Imagine a coronal mass ejection, a colossal, million-ton glob of charged plasma expelled from the sun's outer atmosphere, clashing with a comet's fragile ion tail. The resulting pressure front and field warping can squeeze, warp, or outright snap the tail, in sequences spanning hours that yield some of the most captivating comet images imaginable. These tail severance incidents happen when the solar wind's embedded magnetic field flips polarity swiftly, overwhelming the comet's current tail setup. The old tail gets left behind, floating off as orbital junk, as a fresh one starts to take shape amid the altered magnetic field. For those not versed in space weather dynamics, such occurrences often seem downright otherworldly. A comet's tail could abruptly form twists, tangles, or helical patterns that challenge the basic principles of gas flowing outward from a core body. It might even look like the tail has snapped completely, fostering the misconception of some external force striking or harming the comet. In truth, these striking occurrences are just standard reactions to atypical conditions from the sun. The comet proper stays unscathed. It's solely the delicate stream of charged particles in its tail that reacts to shifts in the magnetic surroundings. Yet the spectacle is so striking that onlookers tend to chase bizarre theories instead of recognizing everyday space, weather as the culprit. This solar role is especially pertinent to our analysis, given that every one of the 8 bodies we're examining, 7 classic comets and the 3I/Atlas, encounters identical space weather patterns. Each faces the identical outbursts of coronal mass, identical blasts of swift particles, and identical fluctuations in magnetic fields typical of peak solar phases. Should vivid tail disruptions happen at the same time in several comets, the simplest rationale points to collective reactions to shared solar prompts, not some enigmatic interplay among the bodies. One massive solar flare-up can impact tails across the inner solar system, producing a false sense of harmony unrelated to any interplay or signaling between comets. The ramped-up solar output in 2025 likewise influences Earth's magnetic shield, heightening the sense of spectacle in our exceptional comet season. Storms in the geomagnetic field, sparked by incoming solar particles, can scramble satellite signals, jam GPS signals, and in severe instances, endanger power networks. In more obvious ways, such events shift the auroral belt's equatorward, enabling people in mid-latitude spots to catch the shimmering displays usually confined to high-latitude areas. Pairing vibrant comets with vivid auroras yields a celestial display so potent and synchronized it borders on the uncanny. However, it's essential to differentiate true causation from mere coincidence here. Solar eruptions influence both comet tails and Earth's magnetic field alike, yet comets play no part in sparking geomagnetic upheavals. The Sun propels these processes separately, yielding overlapping timings that suggest no direct link between comets and ground-level effects. Such clarity proves essential in assessing assertions tying 3I/Atlas to diverse earthly events. Should COM's satellites glitch or grids falter as the interstellar guest swings by, solar dynamics offer a much sounder account than any arcane pull from a remote minor body. The alignment of solar peak with our odd comet influx sparks fascinating inquiries into possible links between solar rhythms and comet detection or inbound timings. Does heightened solar output somehow spur more comets to head inward from the distant solar fringes? Could gravity or electric forces tied to solar highs tweak when comets reach us? These probes dip into conjecture, yet stay anchored in observable data. Solar patterns adhere to thoroughly recorded rhythms that ought to imprint clear marks on comet inbound records if real ties hold. Archives covering various solar eras might show if lively solar times align with boosted comet surges beyond mere luck. Our probe demands meticulous disentangling of solar impacts from any ties between 3I/Atlas and the 7-comet cluster. Upon spotting odd-tail antics, our initial step must be to scan space weather alerts for coronal ejections, rapid solar winds, or other verified solar catalysts. Merely once we've factored in established solar roles can we fairly entertain wilder ideas for what we see. This systematic method averts hasty judgments born of overlooking routine drivers for flashy ones. Expert space weather setups deliver instant info on solar happenings, enabling exact matches to spotted comet actions. Instruments like the Solar and Heliospheric Observatory, the Solar Dynamics Observatory, and terrestrial magnetometer arrays steadily monitor solar states and their spread across the space between planets. Such setups afford us remarkable capacity to tell apart sun-prompted comet actions from truly odd happenings that could signal something else. Influences from sources beyond our sun could subtly alter the dynamics of conventional comets, and any such impacts ought to stand out amid the usual fluctuations of solar output. Hobbyists around the globe play a vital role in tracking these phenomena, bolstering the efforts of official space weather monitoring setups. Photographers capturing comets from various locations record details on tail formations, luminosity shifts, and morphological alterations with a level of detail and frequency that surpasses what overworked research facilities typically manage. This global array of observers ensures round-the-clock surveillance of all our celestial visitors, generating extensive archives that enable precise examinations of links between solar dynamics and comet responses. The fuller our data collection becomes, the surer we grow in spotting truly exceptional occurrences worth deeper scrutiny. With heightened solar events expected in 2025, our study of these comets will play out amid a surge of space weather incidents. Such a lively solar backdrop promises plenty of chances for stunning comet imagery, even as it muddies the waters in detecting faint effects that occur separately from solar-driven ones. The key is upholding rigorous criteria for proof while staying receptive to real oddities that could uncover hidden facets of comet responses. The cosmos has caught us off guard in the past with faint ties that once appeared implausible, and peak solar phases may supply the intense setting required to spot minor interaction signals. As we gear up to explore space weather's role in terrestrial conditions, keep in mind that our sun's actions fuel nearly all the striking displays tied to lively comet eras. The issue at hand is not if solar dynamics shape comet activity. That link is solidly proven. But if other forces join in, operating beside solar ones in manners unforeseen by existing models. The interstellar ballet persists, directed by flux lines and charged flows that bind our central star to each body in its pull. Yet amid this known routine, fresh movements may lie ready for revelation. Part 10. Ripples reaching Earth. Space weather's effects on our world weave a tangled array of risks to tech networks that few ponder until breakdowns hit without warning. Though comets offer no immediate danger to Earth themselves, the ramped-up solar vigor that heightens their visual drama can devastate the digital backbone sustaining contemporary society. Geomagnetic disturbances, Earth's reaction to incoming solar particles, may spark currents in electrical grids, risking overloads on transformers and sparking widespread outages. The event in March 1989 that shut down Quebec's power network illustrated just how space weather can spawn real-world fallout affecting vast populations. Orbiting satellites endure even starker threats from solar particle assaults. Energetic protons and electrons, sped up by solar flares, can breach protective barriers, leading to brief glitches or lasting harm to delicate circuits. Systems for GPS positioning, orbital relays, and atmospheric surveillance all lose dependability amid fierce solar bursts. Air travel introduces further risks, especially on routes near the poles, where the planet's magnetic shield offers scant defense against incoming rays. Carriers often adjust paths during major geomagnetic events to shield travelers and staff from rising radiation doses and to safeguard onboard gear from solar disruptions. These repercussions foster a risky mindset for assessing ties between sky spectacles and ground issues. When comet surges align with solar peaks, the overlap feels suspiciously timed. Grid failures, signal losses, and routing errors seem to point to otherworldly sway from our rare cluster of 7 comets. In truth, things are more ordinary yet just as intriguing. Solar eruptions impact both comets and our tech via unrelated pathways. Comets react to denser particle flows and shifting magnetic realms in the void. Our planet's setups respond to those same streams upon clashing with Earth's magnetic envelope. The overlap stems from a shared solar origin, not from comets meddling in earthly affairs. This nuance grows essential amid talk of 3I loss. Should orbital tech glitch or grids falter as these interstellar travelers approach, solar forces offer a much sounder rationale than any straight hit from a tiny far-off comet. The urge to link resisting the urge to link dramatic occurrences with enigmatic cosmic triggers is essential, prioritizing well-verified physical processes instead. Agencies tasked with overseeing space weather have built advanced alert networks that follow solar disturbances from their start in solar flares, via their travel through interplanetary regions, all the way to their effects on Earth's magnetosphere. The Space Weather Prediction Center under the National Oceanic and Atmospheric Administration delivers predictions and alerts with the identical intensity used for ground-based extreme weather incidents. Such surveillance tools enable exact alignments between recorded space weather occurrences and any tech glitches that align with atypical comet movements. Should breakdowns in infrastructure happen amid confirmed geomagnetic disturbances, solar origins prove much more probable than obscure comet impacts. The intensified solar output expected in 2025 will offer plenty of instances for these kinds of linkages. Under solar maximum phases, geomagnetic upheavals arise multiple times monthly, yielding abundant possibilities for alignments by mere happenstance between system malfunctions and comet sightings. Statistically, certain alignments will emerge just from randomness, irrespective of real causal ties. Hobbyists and amateur radio serve as another vital observation layer, frequently spotting space weather impacts ahead of formal alerts. During geomagnetic disruptions, the passage of radio signals via Earth's ionosphere shifts profoundly, leading to signal outages or odd propagation behaviors that seasoned users spot right away. This widespread detection setup supplies instant insights into space weather states, aiding in separating solar-rooted occurrences from odd ones that could hint at alternative factors. If the 3I Atlas somehow influences Earth's electromagnetic field, such impacts ought to show up across various standalone detection platforms. The approach to inquiry demands ongoing watchfulness against mistakes in assigning causes, which crop up when several striking incidents happen at once. People's minds naturally lean toward linking things causally based on timing overlaps, especially if the alignment feels significant or intentional. The odder each event on its own, the stronger their joint appearance seems. Yet, data crunching shows that seeming bunches pop up often even in completely haphazard setups. Keep tossing a coin over time, and you'll hit streaks that look unbelievable yet are predictably bound to happen mathematically. That logic extends to ties among space weather happenings, comet behaviors, and tech breakdowns. The key difficulty is crafting impartial standards to tell apart true linkages from the groupings that spontaneously form in intricate setups. This involves setting normal benchmarks for how often different event types might overlap by accident alone, followed by checking real-world overlaps against those probability models. Experts in space weather studies have crafted refined methods to tackle these issues. Techniques like superposed epoch analysis, cross-correlation functions, and similar stats approaches measure the robustness of bonds between event categories, while handling the issues from checking loads of possible links at once. These evaluation strategies offer structures for assessing assertions about links between 3I Atlas and Earth-based events, without falling prey to the human tendency to overvalue patterns that turn coincidences into seeming significance. Evidence thresholds need to stay rigorously elevated to dodge unfounded alerts, yet alert enough to catch actual indicators should they appear. The worldwide reach of today's tech networks generates endless chances for seemingly linked celestial happenings and operational glitches. With millions of orbiting satellites, billions of gadgets, and endless data lines running non-stop, daily mishaps happen for ordinary, chance-based causes. In times of elevated comet presence or quirky solar patterns, these everyday issues draw extra scrutiny and risk of wrong blame. A blackout, typically chalked up to worn-out gear or upkeep lapses, could get pinned on bizarre comet forces if it hits during a surge in skywatching buzz. Spreading knowledge and straightforward messaging turn crucial for curbing these mislinks. The better folks grasp the real ways space weather impacts ground tech, the less they'll reach for outlandish answers when standard physics covers it fully. This awareness aspect carries over to our probe into possible ties between 3I Atlas and the cluster of 7 comets. By distinguishing firmly between proven causal links and hypothetical scenarios, we can delve into intriguing ideas without elevating baseless ideas to the status of verified truths. The advanced technology of today's society offers both prospects and obstacles in identifying faint impacts that fall beneath the usual boundaries of standard space weather phenomena. Our heightened awareness of electromagnetic occurrences could enable us to pick up on delicate signals undetectable by earlier eras. Yet, this also heightens the risk of spurious links and wrongly assigned origins. As we gear up to investigate the ways in which human cognition and societal stories influence our views of heavenly occurrences, keep in mind that the cosmos adheres to unchanging physical principles, irrespective of our desires for sensational findings. The planet's reactions to space weather adhere to familiar processes that need no outlandish rationales. Even amid phases of exceptional comet swarms, the remnants of solar flares echo across our tech infrastructures in foreseeable ways that we can quantify, scrutinize, and trace back to their true roots. However, amid the fluctuations of routine space weather patterns, faint indicators might linger, ready for capture by tools precise enough to separate mere association from true cause. This inquiry presses on, rooted in solid scientific principles, yet open to notions that could test our present grasp of the interplay between sky-based and ground-level happenings over immense distances and durations. Part 11. Omens of Transformation. Across the span of human existence, vivid comets have acted as stellar heralds that societies have read through the lens of their profound anxieties and grandest dreams. The emergence of several comets at once resonates with mental habits that have steered human actions for thousands of years, turning neutral stellar happenings into personal tales of destiny, shift, and universal import. Early Chinese sky watchers kept detailed logs of comet sightings, tying them to shifts in ruling houses, catastrophes from nature, and societal disruptions. Accounts from the Han Dynasty portray comets as sweeping stars that clear out outdated regimes to pave the path for fresh starts, an image that highlights how past societies have perpetually hunted for purpose in the rhythm of the heavens. In medieval Europe, record-keepers viewed comet showings as heavenly alerts of looming calamities or pivotal shifts. The prominent comet of 1066, which surfaced just prior to the Norman takeover of England, got eternally tied to the collapse of Saxon authority and the reshaping of English life. Debate persists on whether the comet truly swayed outcomes or merely supplied handy imagery, but the association firmly lodged in the annals of history. The 1758 reappearance of Halley's Comet aligned with the 7 Years' War, a worldwide clash that redrew political maps on 3 continents. Settlers in colonial America regarded the comet as a sign of liberation from British control, whereas astronomers in Europe hailed it as proof of Newton's ideas on gravity. Identical sky phenomena fueled entirely distinct tales based on varying cultural backdrops and political goals. Such past instances show how our brains inherently weave grouped extraordinary occurrences into unified accounts that seem deeper than mere chance. When various striking developments coincide, be they comets, conflicts, epidemics, or civic turmoil, we naturally hunt for hidden ties instead of embracing separate origins. This drive to find patterns intensifies especially in times of communal strain or doubt. As groups eagerly look for indicators of what's ahead, the 2025 comet cluster emerges in a time of swift tech evolution, environmental worries, and international strains that till rich soil for seeing sky events as signals of upheaval. Today's media networks boost these timeless mental responses via tools that would baffle those old European scribes. Algorithms on social platforms favor captivating material over precise information, making sure that striking comet clips and conjectural ideas circulate quicker than measured stellar breakdowns. The brain circuits that formerly aided in spotting real designs in wild surroundings now react to online triggers crafted to seize and retain focus. Tools for video manipulation let hobbyist makers craft persuasive tales blending authentic comet footage with evocative sounds, intense voiceovers, and thoughtfully chosen graphics. These works can match expert quality even as they push ideas that no scientific scrutiny would endorse. The broadening access to content creation in the digital age empowers anyone connected online to shape ongoing tales surrounding astronomical phenomena. Independent contributors frequently align on comparable viewpoints without any deliberate collaboration, fostering an illusion of broad agreement on concepts that may not hold up to scrutiny. This collective narrative building can swiftly elevate basic sightings, like the arrival of 7 comets in 2025, into intricate stories hinting at universal importance, extraterrestrial contact, or looming catastrophe. With each iteration, fresh elements, links, and viewpoints emerge, steadily pulling away from confirmed data into unbridled conjecture. The inclusion of 3i Atlas in such a setting offers prime territory for imaginative spins. An object from beyond our solar system showing up amid our atypical year of comets delivers precisely the sort of enigmatic synchronization that our minds perceive as intentional rather than chance. The tale essentially crafts itself. An extraterrestrial device syncs with the comet cluster to convey a signal or alert to our planet. Such accounts fulfill various mental cravings at once, offering rationale for odd alignments, granting purpose to seemingly haphazard occurrences, and casting everyday stargazers as key figures in epical happenings. Established astronomers confront growing difficulties in vying for audience engagement against these captivating yarns. Meticulous breakdowns of celestial paths and chance calculations pale in comparison to the heartfelt draw of narratives that turn watchers into active players in interstellar theater. When experts convey research gaps as spectrums of options instead of firm verdicts, it comes across as less commanding than bold declarations of concealed intents. Upholding truthfulness amid these dynamics demands unwavering watchfulness to avoid exaggerating findings or downplaying real ambiguities. By noting that certain patterns surpass expected odds, yet stressing that links do not imply cause, we hazard disengaging listeners in favor of outlets peddling clearer resolutions. Still, this tension opens doors for learning in astronomy that standard public efforts seldom reach. The intense curiosity around our probe into the 7 comets generates ideal chances to explore idea validation, data crunching, and the gap between proof and supposition. Through clear divides between proven elements and hypothetical angles, We illustrate methodical inquiry, even as we probe notions that test established limits. Our inquiry turns into a lesson in analytical reasoning, showing why bold assertions demand robust backing without rejecting odd data outright for mere unlikelihood. The societal filters individuals use to process our results will inevitably color their takeaways, no matter the proofs offered. Those hunting validation for interstellar guests will see vague outcomes as bolstering their favorite ideas. Doubters wedded to standard views will brush off robust associations as insufficient for unconventional origins. This divide mirrors profound debates on knowledge foundations, how we gauge trustworthy information, and enough support for embracing atypical propositions. Varied groups employ distinct criteria drawn from their backgrounds, expertise, and beliefs about existence. Science calls for tentative endorsement of outcomes grounded in current info, all while staying receptive to updates from emerging details. This modest mindset might seem feeble next to the assured conviction of fervent supporters or staunch disbelievers. However, such adaptability marks science's core power in separating true breakthroughs from mere fantasies. Astronomy's past is rife with cases of once ludicrous notions validated by mounting proof, alongside persuasive models that crumbled under sharper scrutiny. Our scrutiny of ties between 3I Atlas and the 7-comet cluster needs to steer through these societal and mental flows without getting swept up. The data will make its case, provided we uphold fitting evaluative norms and stay attuned to hints that could upend standard views. As we gear up to tackle the most dramatic facets of societal guesses tied to our comet study, keep in mind that humanity's draw to stellar enigmas stems from authentic awe at our cosmic role. The key is directing that awe toward inquiries resolvable by thorough scrutiny and examination reveal that the early stargazers who interpreted portents in comet narratives weren't completely off base. Events in the heavens do offer insights into vast cosmic mechanisms that influence human societies, though the links function via physical laws instead of mysticism, and grasping them calls for instruments far more advanced than gut feelings or ancient lore. The omens have materialized, bearing tidings inscribed in the common tongue of celestial orbits and spectral readings. Yet before that, we must unravel the vivid human explanations that always cluster around such enigmatic occurrences. Section 12. The Extraterrestrial Theory. The boldest take on our cluster of 7 comets demands guts to state outright. 3I Atlas serves as a constructed scout from a distant society, with the classic comets forming an organized armada reacting to its entry. This idea ventures well past standard stellar science into realms of conjecture that call for exceptional proof. Still, its potential ramifications are so weighty that rejecting it outright without probing would be just as unrigorous. We'll explore what a true manufactured source might entail, viewed through the framework of proven science rather than wild speculation. A crafted device journeying amid star systems would have to tackle issues that test our present engineering limits. Drive systems for crossing vast interstellar gaps, pinpoint guidance over spans of millions of years, and signaling over light years of void. The power needs alone overwhelm our grasp. Boosting even a modest craft to the paces needed for star-to-star voyages requires energy generators that eclipse our existing tech. Options like atomic burst drives, matter-antimatter reactors, or undiscovered exotic forces would be essential to hit velocities allowing transfers between stars in sensible durations. Steering poses similar formidable hurdles. 3I Atlas's path shows stunning exactness in aiming for our solar realm from possible starting zones hundreds of light years away. That level of precision hinges on in-depth awareness of star locations and shifts over eons, implying surveillance tools and processing power vastly superior to ours. Yet these technical obstacles, though formidable, align with accepted physical laws. Mature societies could plausibly craft solutions to interstellar journeys by sheer exploitation of principles we know but can't yet harness. The real issue isn't if such scouts are conceivable in theory, but if 3I Atlas displays traits setting it apart as built rather than formed by nature. Spectral study gives our sharpest method for spotting contrived makeup. Typical comets exhibit glow patterns tied to frozen water, carbon-based stuff, and basic chemicals that arise easily in the frigid fringes of star systems. Built scouts could harbor fabricated substances, purified ores, rare metal mixes, or lab-made elements absent from natural comet zones. A close look at 3I Atlas's light signature ought to show if its makeup fits standard icy body expectations or bears marks hinting at human-like creation. Spotting unmistakable engineered materials would offer strong proof of deliberate design, whereas all natural readings would robustly counter the built origin idea. Pattern study provides a further path to uncover synthetic signs. Standard comets trace gravity-driven arcs shaped solely by poles and sporadic jets that yield minor but trackable pushes. Constructed scouts could show path adjustments, orientation shifts, or maneuvers signaling deliberate guidance over mere drift with surroundings. 3I Atlas's orbit details reveal no gravitational deviations past those from routine venting. Its course aligns with an inert body obeying natural rules, not clever design. That said, faint steering might lurk under our spotting limits, especially if crafted to ape comet norms. Signal traces might deliver the clearest gauge of built origins. Active craft would probably link back to makers via radio waves, light beams, or other energy bursts catchable by Earth-based scopes. The Hunt for Alien Minds group has methods to sift these emissions and separate crafted from cosmic noise. Routine scans of 3I Atlas over various wavelengths have picked up no clear synthetic broadcasts. Although the review persists as the entity draws near as the interstellar object draws nearer to our planet, the lack of observable signals doesn't rule out the chance of an engineered source, given that highly evolved societies could employ transmission techniques beyond our imagination or on wavelengths we aren't scanning. The idea of orchestration pushes the notion of artificial beginnings further, implying that our cluster of 7 classic comets might form a purposeful armada reacting to the newcomer dubbed 3I Atlas. This concept demands even bolder leaps regarding cutting-edge tech and tactical orchestration over vast cosmic spans. Every piece in this comet group would require standalone drive systems and guidance tech advanced enough to sync up their arrivals in tight temporal slots. The sheer complexity of pulling that off defies our wildest notions. Imagine 7 distinct bodies dispatched from varied origins at disparate moments, all converging within mere months following odysseys that lasted thousands of years. Still, the paths of these 7 established comets bear unmistakable signs of native solar system birth. Their makeup aligns with projections for bodies originating in the distant reaches of our system. Records of their spotting go back to established observation initiatives that have monitored them for years, sometimes longer. Their flight paths display no hints of deliberate adjustments or synchronized adjustments. Should these be deemed constructed artifacts, they'd involve camouflage so ingenious as to flawlessly imitate genuine comets from our own system. Achieving that level of ruse would necessitate intimate familiarity with our observational tools and assumptions, pointing to monitoring and evaluative prowess that outstrips their visible tech feats. The overlap in timing between 3I Atlas and our comet assembly stands as the most compelling case for potential interplay. Though the how remains elusive, crunching numbers on comet sighting trends might uncover if 2025 marks a true outlier in groupings that go beyond what randomness would predict. That said, mere chronology offers slim grounds for engineered linkage when weighed against expanding detection networks and inherent fluctuations in how we spot comets. The boom in robotic sky scans greatly ups the odds of picking up items that evaded notice in earlier eras. Our draw to extraterrestrial theories taps into fundamental urges to spot intent and smarts in what seems like haphazard occurrences. Confronted by odd alignments, we instinctively lean toward accounts featuring deliberate action over embracing that luck alone crafts designs that seem significant yet truly are not. The extraterrestrial angle also eases modern worries about our solitude amid the stars and the bounds of our innovations. Should superior beings be probing our solar realm, it hints we're not isolated in the cosmos, and that progress past our tech horizons is attainable. Yet, bold assertions demand robust backing, and this extraterrestrial view undoubtedly counts as bold. It's up to advocates to furnish proof of synthetic traits that hold up under critical scrutiny, not for doubters to disprove the absence of faint traces. Existing data from observations falls short of backing claims of manufactured routes for 3I Atlas or any in our comet lineup. While we can't entirely dismiss expert disguises that replicate natural forms to perfection, those ideas hinge on suppositions about otherworldly skills and drives that stretch well past what facts support. Probes continue with fresh data that could spotlight traits overlooked so far. Nearer passes will allow for finer spectral breakdowns, sharper pictures, and keener hunts for synthetic emissions or odd behaviors. Experts in astronomy keep a balanced doubt toward outlandish ideas, all while pressing on with methodical watching and review that might catch real signs of artifice if present. Science's approach offers tools to separate hopeful fancy from solid finds, provided it's wielded with due care. Hunting for signs of alien minds ranks among the deepest puzzles for our species. Should proof surface that 3I Atlas or linked items show true signs of human-like design, it would reshape how we see our cosmic footing. But absent data that clears the high bar to sway cautious experts, the extraterrestrial idea lingers as conjecture, not confirmed reality. The awe and potential endure, even as we recognize recent findings continue to support standard scientific interpretations rather than speculative ones. As we delve into the more sensational ideas that people's creativity has spun around this atypical comet season, it's worth noting that upholding rigorous science doesn't mean we have to dismiss intriguing ideas that question established views. The cosmos has caught us off guard in the past with occurrences that once appeared utterly improbable. Part 13. The Apocalypse Outlook. The most ominous take on our cluster of 7 comets depicts 2025 as a period of existential peril to society, masterminded by powers outside our grasp. This apocalyptic tale recasts orbital dynamics as interstellar conflict, converting frozen debris and stone into instruments that could conclude humanity's story. Though these plots fuel gripping stories, appraising them demands a straightforward review of true dangers compared to the anxieties tied to rare sky phenomena. Authentic collision threats adhere to established physical principles, enabling exact computations of strike odds and outcomes. Should asteroids or comets near Earth on paths that could cross our world's orbit, expert skywatchers can forecast and mitigate such situations with numerical accuracy. The laws of motion dictating these projections function with mechanical exactness, eliminating uncertainty about real strike dangers. Not a single one of our 7 comet participants traces a path presenting any strike danger to our planet in their present passes. Pan-STARRS, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and NEAT all hold distances in the millions of kilometers. Their nearest passes keep them well outside the pole regions that might trigger disastrous clashes. 3. Atlas pursues a hyperbolic path that steers it clear of all key solar system features. Its origins from beyond our system and swift pace compared to local bodies in fact lower the chances of collisions instead of raising them. For items traveling at such hyperbolic rates, gravity can't pull them into orbit, so while the lack of strike danger removes that worry, it doesn't rule out every peril linked to ramped-up comet presence. Disruptions from space weather, fueled by peak solar conditions, can endanger tech setups in manners that today's society finds hard to handle. Power networks, satellite links, and GPS arrays all show weaknesses amid fierce solar radiation storms. However, these tech vulnerabilities arise from the sun's actions, not the comet's. The sun's 11-year cycle of magnetic flips hits its peak in 2025, unrelated to incoming comets. The overlap in timing between lively comets and lively sun phases mirrors a common reaction to broader solar system patterns, not comets dictating solar patterns. Gauging dangers calls for data-driven review that distinguishes real perils from the sorts of random groupings that our pattern-hunting minds deem significant. When several unlikely incidents happen at once, gut-level danger judging typically inflates the odds of some orchestrated menace unfolding. Expert danger evaluation uses analytical tools that adjust for the pitfalls of multiple tests when probing lots of event links at once. In scanning numerous potential ties across event types, certain seeming links will surface just from luck, without any true cause and effect ties. The apocalypse view builds emotional appeal by lumping our 7 comet group plus 3Y Atlas into one menacing whole, instead of viewing each as a standalone occurrence. Such grouping turns 7 distinct minor risk happenings into what looks like a major risk crisis urging urgent attention and readiness. But the rules of orbital paths ignore these made-up groupings. Every body charts its course shaped by pull forces acting separately on each comet. The seeming sync lives in our mind's eye, not in tangible facts, born from when we spot them rather than real interplay among them. Past examples offer insight into how odd sky sights connect to earthly calamities. Striking comets have shown up amid wars, epidemics, shortages, and societal turmoil across history's records. Yet thorough review uncovers no data link between comet showings and higher human disaster rates. The sense of linkage stems from how standout heavenly displays draw extra focus in eras when folks are already burdened by ground-level woes. Records from tough periods inevitably highlight any strange signs that could relate to current hardships, while similar rare astronomical occurrences in times of calm tend to draw little historical scrutiny. Today's society confronts real existential dangers that warrant careful consideration. Atomic conflict, global warming, infectious outbreaks, and tech upheavals all present serious dangers to humanity's well-being. These perils function via clear pathways that experts can examine, simulate, and possibly lessen with targeted strategies and readiness measures. The apocalyptic comet idea diverts focus from these authentic perils by emphasizing issues that offer scant real peril to human society. Diverting scarce focus and funds to fictional dangers weakens our shared capacity to tackle true issues demanding ongoing work and teamwork. Dramatic assertions regarding stellar perils should satisfy stricter proof requirements than offhand guesses about odd alignments. If a person claims our comet cluster endangers society on a grand scale, we require detailed processes, numerical odds, and independently confirmed proof over fuzzy remarks on dubious timing. The scientific approach offers tools for assessing such ideas impartially. Experiment validation, data crunching, and expert scrutiny aid in separating valid worries rooted in facts from baseless worries stemming from mental shortcuts instead of tangible perils. Crisis response organizations run advanced surveillance networks that follow actual cosmic weather dangers and evaluate their effects on vital systems. Such networks would spot and alert on any true dangers from boosted comet surges or peak sun activity well ahead of any impact. The lack of alerts from groups tasked with cosmic weather oversight powerfully counters ideas forecasting sudden, systemic breakdowns from comet-linked events. Expert hazard evaluators, equipped with the fullest data sets, detect no signs of exceptional dangers needing urgent action. Spreading awareness of genuine cosmic weather perils fosters a balanced view of the gap between flashy displays and real perils. Sun flares can truly endanger tech setups. Yet those perils work via known channels that allow forecasting, tracking, and countering with technical fixes. The ramped-up comet action in 2025 will deliver stunning viewing chances and key insights into solar system patterns. These gains vastly surpass any practical dangers tied to the viewing itself. The true danger emerges when baseless alarms eclipse valid scholarly interest and learning prospects. Ethical science outreach demands frank recognition of unknowns while keeping a sensible gauge on the magnitude of real perils. When we note that parts of our comet study stay unresolved, we should stress that unresolved doesn't imply hazardous. The cosmos routinely generates events that test existing knowledge without endangering humanity right away. Scholarly advancement relies on probing such events methodically, steering clear of hasty judgments drawn from partial data or mental pitfalls. As we gear up to dissect the wildest plot ideas that human imagination has spun around our odd comet season, keep in mind that bold statements on stellar perils demand bold proof to earn real debate. Worry-driven guesses hold no value when cut off from strict review of true odds and pathways. The end times plot says more about human mindsets than about stellar mechanics. Our brains wired for patterns naturally view grouped odd happenings as orchestrated dangers instead of chance clusters, especially in tense social times when folks hunt for answers to their unease. Yet the cosmos runs by physical rules unmoved by human dreads or hopes. Comets trace gravity paths computable with accuracy. Sun patterns follow magnetic rhythms forecastable via stats, and cosmic weather impacts adhere to electrical rules measurable and simulatable. The stellar machinery keeps its exact rhythm no matter the thrilling tales we weave about its boldest shows. Grasping that machinery yields real-world gains and deep fulfillment beyond the fleeting rush of end times guesses. Part 14. The Invasion in Disguise. The wildest plot notion tied to our 7-comet event posits that we're seeing the early stage of an alien incursion. An invasion masked by seemingly ordinary celestial occurrences. Here, the Atlas functions as a central hub, directing a group of entities posing as classic comets, all while scouting and gearing up for a future takeover of our solar system. This theory demands a level of technical prowess that defies human understanding. Every supposed scout would require shielding tech capable of flawlessly replicating the spectral profiles, vapor release patterns, and path dynamics of authentic comets in our solar system. Achieving such subterfuge calls for deep insight into our observational tools and a thorough grasp of how real comets act when exposed to sunlight. Think about the design hurdles in building fake entities that could deceive our top-tier equipment. Today's spectral analysis can pinpoint chemical compounds with remarkable accuracy, spotting differences in isotope proportions that indicate their origins and reactions. Any man-made device would have to incorporate substances identical to those anticipated for items originating from the distant reaches of our solar system eons ago. The vapor emission that forms comet tails poses similarly tough masking demands. True comets gain their distinctive look via the evaporation of icy substances in the sun's warmth, a mechanism tied to their makeup, layout, and heat-handling traits honed over vast epochs. Faking this would necessitate intricate design to imitate it convincingly. Brightness profiles, the shifts in luminosity defining comet activity, offer yet another way to spot synthetic origins. Genuine comets usually exhibit gradual light fluctuations, interrupted by sporadic flares as new icy layers surface. The spin rates shown in these changes echo the chaotic rolling of odd-shaped bodies with little internal cohesion. Should our 7 standard comets turn out to be engineered creations, their brightness patterns would sooner or later expose traits setting them apart from organic ones. Signs of deliberate spin management, scheduled light shifts, or hints of ongoing orientation adjustments would surface via ongoing light measurement. The path traits of these covert scouts create the core masking difficulty. Every item in our comet cluster traces a route that stretches back through eons of gravitational influences. These path records bear imprints from their birth zones, close planetary passes, and poles that molded their present courses. To craft synthetic items with paths matching natural solar system residents, they need to be released from suitable ranges and angles, ensuring their arcs align with projections for bodies born in particular outer solar system areas. The practicalities of executing this over cosmic expanses and immense timescales strain belief. Furthermore, the detection timelines for our 7 comets link to established observation efforts that have monitored them for years or even decades. Efforts like NetLemon and the Atlas program hold detailed logs of each find's context and the follow-up path calculations that predict their approach dates. If these were fresh synthetic arrivals instead of long-orbit comets finishing organic loops, their abrupt entry into observation records would have sparked instant scrutiny from path experts. The lack of such flags points convincingly against ideas of lately placed fakes impersonating classic comets. The signaling needs of an organized invasion armada provide more chances for spotting them. Keeping 7 spread-out units plus a lead ship in sync would demand regular info swaps via radio waves, laser links, or similar energy signals that Earth-based watchers could pick up. The hunt for alien intelligence field runs advanced radio dishes that routinely scan huge sky swaths for man-made emissions. Initiatives like Project Breakthrough Listen, remnants of the Arecibo Observatory efforts, and many others conduct ongoing hunts for the precise sorts of synthetic pings that fleet coordination would generate. No picked-up artificial emissions tied to our comet group doesn't rule out every signaling option, as superior societies could use techniques evading our present sensing tech. Yet, the orchestrated maintaining fleet operations over solar system spans would probably demand signal intensities and relay sequences detectable by modern equipment. The rationale behind covert invasion plans raises core issues concerning efficiency and hazard control. For what reason would interstellar-capable societies opt for such intricate ruses, when a straightforward advance could accomplish scouting goals more effectively? In what way does concealment offer tactical benefits against a target society defenseless against spacefaring tech? The expenditure of materials needed to produce and position 7 advanced stealth probes, along with a control ship, would surpass humanity's total economic production by vast multiples. Societies with the capacity for these outlays would hold tech edges so dominant that trickery loses all tactical value. Moreover, the takeover model presumes aggression without signs of aggression from spotted entities. Our comet cluster's components display no functions exceeding those of ordinary celestial bodies. Notably, IA Atlas is on a path that will eject it forever from the solar system, which doesn't align with setting up a lasting foothold for conquest. The draw of takeover narratives mirrors current worries over tech upheavals, fights for resources, and erosion of human autonomy against superior powers. These concerns latch onto odd sky events implying influences outside human grasp or comprehension. Yet imaginative guesses about alien motives can't replace solid data on the makeup and actions of spotted items. The takeover idea demands clear proof of man-made traits, synchronized actions, or menacing features, instead of depending on the lack of confirmation that items are wholly natural. Existing sighting records offer zero backing for man-made origins among any comet cluster parts. Spectral studies show makeups matching natural origins in solar system settings. Path traits fit predictions for bodies shaped by gravity across eons. Activity shows no signs of deliberate guidance or linkage past random chance. Those pushing bold assertions must supply proof of synthetic features that hold up under strict doubt. No such proof doesn't confirm takeover ideas can't happen, but it does suggest present sightings lean towards standard astro-interpretations over wild ones. Expert stargazers keep steady watch on all odd bodies just to spot any hints of synthetic origins. The field treats these options with gravity, upholding set procedures for assessing possible alien relics while enforcing proper proof levels to separate guesswork from real finds. The probe goes on as nearer passes allow finer scrutiny of item traits and patterns. Should true synthetic markers be there, they'll grow clearer as sighting tools advance and more info builds up. Sci-fi tales play useful roles in probing options and building mental models for surprise finds. But their fun factor doesn't warrant pushing unproven tales as truth when facts are at hand. Proof doesn't back bold assertions. The cosmos holds plenty of real enigmas without us needing to dream up extra riddles from hopeful fantasies or panic-fueled guesses. Our 7-comet cluster marks a real oddity in stats deserving study. Yet that study ought to chase clues, not preset ideas on assault armadas and stellar plots. As we gear up to merge our probes, results, and verdicts, keep in mind that upholding scientific discipline doesn't mean ditching awe at space's potentials. The methods of fact-based probing that sort truth from illusion also equip us to spot true breakthroughs when stunning proof emerges at last. The universe might still stun us with events that upend standard views, but those shocks will come via precise watching and review, not jumps past what clues show. Part 15. The cluster's signal. Following months of study, plotting path dynamics, weighing chance odds, and probing all imaginable conditions, the link among 1I/Oumuamua and the cluster of 7 comets in 2025 underscores a finding that's both comforting and astonishing. What we're observing is a stunning display of nature's workings, not signs of unusual orchestration or alien meddling. This group of 7 comets marks a true instance of statistical grouping that draws our gaze exactly because these gatherings happen infrequently enough to seem profound. Pan-stars, Swan, Stereo, C/2019 K1, Atlas, C/2023 G3, Atlas, Lemon, and Neat each trace distinct paths through space, guided by gravitational pulls that started molding their courses eons ago, well before any human societies could observe their eventual alignment. Still, brushing off this alignment as simple chance overlooks the deep elegance and research potential in this event. The cosmos has orchestrated a stellar celebration, offering rare chances for in-depth comet comparisons, astronomy outreach to the public, and greater insights into the mechanics of the distant solar system. Though the schedule is purely organic, its effects on science and society are truly exceptional. One Eye / Oumuamua brings yet another dimension of awe as the initial thoroughly recorded interstellar object from our solar system, displaying evident cometary traits. This entity bears frozen water and particles formed near a distant sun, tempered by eons of wandering through the void, now sublimating in our star's warmth to unveil narratives of otherworldly compositions detectable by global observatories. The overlap in timing between this wanderer from beyond and the busiest comet season in living recollection keeps scientists captivated. While data so far indicates happenstance over deliberate links, the cosmos often crafts patterns that evoke purpose via ordinary mechanisms, illustrating how randomness and relevance can overlap without needing enigmatic causes. Probes into the matter have uncovered no ties in orbits, odd behaviors, or schedule alignments beyond what probability models forecast for separate bodies affected solely by standard gravity and sunlight warming. Every comet narrates its unique history of origins in the solar system's fringes, disruptions from gravity that set its path, and reactions to intensifying stellar rays as it nears closest solar approach. This outcome doesn't lessen the thrill of discovery tied to 2025's atypical sky events. A series of vivid comets enables side-by-side analyses seldom seen in one viewing window. Experts can examine varying makeups, dimensions, and path shapes under comparable solar influences, pushing forward knowledge of comet mechanics that single sightings alone can't match. The boosted sunspot frenzy during peak solar cycle will heighten the visual drama of this comet lineup while offering real-world tests in solar weather science. Those very solar flares that challenge our tech grids also spark the striking tail breakups and charged particle chaos that render comet images so mesmerizing amid high solar times. Hobbyists across the globe are capturing this sky party with remarkable clarity, building image collections that will fuel studies for years ahead. The rise of accessible advanced sky imaging lets countless watchers add to data pools that bolster expert surveys, expanding our viewing power far past any lone group's reach. The widespread curiosity sparked by the 7 Comet probe shows how rare sky happenings can ignite passion for cosmic exploration and analytical reasoning. Weighing bold assertions against solid proof offers learning moments that standard stargazing programs seldom provide, highlighting the scientific process's role in separating conjecture from verified truth. Lacking odd ties doesn't rule out fresh findings down the line. Ongoing surveillance could spot faint links overlooked in initial reviews, or nearer passes might uncover traits hidden from today's detection limits. Knowledge advances via gradual gains in tools, accuracy, and methods that sometimes expose once concealed wonders. The grouping seen in 2025 might also shed light on enduring solar system patterns unfolding over spans beyond recorded history. Should such groupings have happened before or follow foreseeable cycles, they could signal gravitational harmonies, sun rhythm impacts, or further rhythmic forces guiding comet timings across vast epochs. Astronomers in the field will keep tracking these systems. Careful monitoring and examination of any atypical celestial bodies remain essential, with ongoing alertness to traits that could suggest manufactured sources or unconventional physical mechanisms. Researchers approach these prospects with due gravity, yet they enforce stringent proof requirements to separate true irregularities from mere random variations in intricate datasets. Our study's wider ramifications surpass the narrow inquiry into links between the three-eyed Atlas and conventional comets within our solar system. This approach highlights the ways in which methodical scientific scrutiny can tackle unconventional ideas without succumbing to the conjecture they spark in mainstream discourse. Striking equilibrium between inquisitiveness and doubt grows ever more vital as digital platform mechanisms spread dramatic assertions more swiftly than thorough reviews can assess them. Experts in the field hold the duty to deliver precise details while candidly admitting gaps in knowledge, rather than vying with amusement-driven material via overstated assertions or hasty judgments. The comet events of 2025 further exemplify how innate human tendencies to identify patterns can convert neutral sky occurrences into personal tales of universal import. Such shifts pose no inherent issue. Deriving purpose and awe from heavenly displays has fueled civilizations across eras, provided one deliberately divides empirical findings from explanatory lenses. Contemporary astronomical methods offer unparalleled means to differentiate real oddities from illusory designs arising from standard probabilistic shifts. These instruments also uncover vast cosmic events that outstrip mortal conception, all without invoking extraordinary rationales, underscoring how actuality frequently outshines imaginative conjecture. As this probe wraps up, we confront a cosmos that proves both more graspable and more enigmatic than common tales imply. It functions via discoverable principles of physics, attainable through meticulous scrutiny. Nevertheless, those principles yield occurrences that defy gut feelings and spur ongoing quests. The 2025 cluster's core lesson might simply affirm that the cosmos delivers ample true marvels, obviating the need to fabricate extra enigmas. The alignment of 7 distinct comets via ordinary dynamics, alongside a lone interstellar traveler's inaugural and sole transit of our system, forms a stellar alignment ripe for admiration due to its sheer improbable synchrony. The learning potential here reaches well past stellar studies into vital reasoning abilities applicable to every sphere of inquiry. Mastering the divide between mere association and true cause, weighing assertions via fitting verification criteria, and sustaining awe amid insistence on precision equips minds with resources that benefit civilization far outside comet probes. Looking ahead, stargazers could recall 2025 as a pivotal moment when enhanced detection technologies and online buzz merged to elevate standard cosmic finds into societal spectacles, drawing millions globally into debates on proof, likelihood, and the essence of empirical wisdom. Perhaps the cluster's final takeaway is that our innate inquisitiveness and discerning prowess, not some arcane stellar orchestration, stand as the true highlights of the affair. Humanity has crafted instruments advanced enough to spot extrasolar intruders, compute trajectories with remarkable accuracy, and scrutinize bold propositions via exacting probabilistic scrutiny. Such feats of ingenuity and cognition merit acclaim equal to any dazzling sky display we observe. Though the cosmos sends no signals via synchronized comet paths, it persists in offering chances for revelation that repay diligent watching with richer insight into our stellar surroundings. This examination ends as it started, marveling at peculiar alignments, honoring exacting review, and valuing a universe brimming with real riddles sufficient to captivate human wonder for ages ahead. Claim assessed, data weighed, all upheld, ready for forthcoming probes stretching past today's sightlines.